Hey guys, welcome back to another video of the electrochemistry series. In this video, we're going to see a few examples of electrolysis calculation. That is, how to find the mass of products produced at any electrode, or how to find the volume of gas released at any electrode. Now, mind you, in electrolysis, that is in an electrolytic cell, where you provide current for the transfer of electrons to take place, for the discharge of ions to take place. Previously, in these videos where I talked about electrochemical cells, in those cases, you don't apply any current. So usually people have this confusion between electrolytic cells, that is where you provide the electricity, and you see discharge of ions taking place and products at each electrode. And there is another where is in these videos where I talked about electrochemical cells, where you don't provide electricity, you connect a voltmeter and you'll see a current or a potential difference between two half cells due to redox reactions taking place, right? So in these cases, the cell potential the electrode potential of the half cells individually provide the flow of electrons. That is, these, when connected, provide the flow of electrons. In our case, in case of electrolytic cells, where is it? In case of electrolytic cells, what happens is there is a current being provided that discharges the ions, forming products at each electrode, right? So in this case, we will be talking about electrolytic cells, right? You're providing the current for the discharge to take place. Okay, so let's carry on with our video. That is to find out the mass produced. So first we'll talk about how to find the mass that is being deposited. Again, this question is made up, so hopefully there is no inaccuracy in this question. But anyways, the question is telling you, find the amount of calcium being deposited if a current of 3.2 amps is passed through molten calcium fluoride for 3 minutes, right? Okay, so step one, what you're going to do is write the half equation for calcium ions. That is what's happening at the cathode, because reduction is going to take place. Oh, by the way, why is it molten in this case? Because if it was aqueous, H plus would actually be discharged because its electrode potential is 0, whereas calcium has a more negative electrode potential, which is why you need molten. Okay, anyways, carrying on with our mass calculation. So first step, what you're going to do is write the half cell equation. That is at the cathode, because you want to find out the mass of calcium. So what's the half cell equation? Calcium ions are going to gain 2 electrons to be discharged, right, to form calcium atoms. Now from this, you find the charge required to form 1 mole of calcium. That is, you can see the molar ratio between calcium and the electrons, it turns out to be 2:1. So to form 1 mole of calcium, we need 2 moles of electron. Now, directly from here, since you know the Faraday's constant, you know the amount of charge being carried by 1 mole of electron. So if you need 2 moles of electron to deposit 1 mole of calcium, how much charge do you need in total? You would need 2 times Faraday's constant. 2 times Faraday's constant. That is giving you, what is this? 193,000 coulomb, right? 193,000 coulombs of charge is required if you want to form 1 mole of calcium. Now, in our case, what will be the charge provided? Because they have given you the amount of current and for how long the current will be passed, right? So using that information, I can find out the amount of charge that will be provided. How? You know, Q is equals to I times, that is current times time. You can find out the charge. That is 3.2 times 3 minutes into 60 seconds. Find it out and you're going to get the charge. That is 576 coulombs of charge will be provided. Now remember, For 1 mole of calcium, I actually need 193,000 coulombs of charge. However, you are providing only 576 coulombs of charge. Therefore, easily you can find out what amount of calcium will be provided by finding out the ratio or the moles of electrons being provided, right? So you are providing 576 coulombs of charge. However, for 1 mole of calcium, you needed 193,000 coulombs of charge. Therefore, 576, that is the amount provided, divided by 193,000, the amount required, is going to give you the mole of calcium that will be produced, right? Because 576 is the mole, not mole. 576 is the charge that you provide, whereas 193,000 is the charge that was required to form how many moles of calcium? 1, right? Okay, so you'll be fine. You'll be having 0.00298 moles of calcium being deposited at the electrode, right? So very easy. Turn it into mass. How do you do that? Mole into molar mass of calcium. That is 440 is the molar mass times the moles of calcium deposited. That is this. So now you know 0.1192 grams of calcium will be deposited at the cathode, right? So what did we do in summary? First, we wrote the half equation. We found out the mole of electron you need to form 1 mole of the calcium atom. Second, we found out the charge required to form 1 mole of calcium, that is 2 times F, that is Faraday's constant. Third step, we found out the actual charge that we are providing, that is 576 coulombs, and then find the moles of calcium that will be produced. How do we find that? Real amount of charge divided by required amount of charge for 1 mole, right? So using that, we can find out the moles of calcium that will be produced, right? Fair enough. If you find the moles, then just multiply by molar mass and you'll find the total mass. Mind you, if I had given exactly 193,000 divided by the needed amount, 193,000, then in that case, we would have cancelling out 1 mole of calcium atom being produced, right? So that's how the ratio works. Okay, so this is how you can find the mass of any atom being deposited at the cathode. Okay. So now in case of volume, if we carry on with the same question, because in case of calcium fluoride molten, I mean in this case molten or not doesn't matter, because if I'm not wrong, I don't remember the electrode potential, but even if it was, even if in this case if it was aqueous, fluorine gas would still be evolved at the anode, right? Okay, fair enough. So in this case, to find the volume of fluorine gas being evolved, what are you going to do? The same few steps up till finding the moles, because after finding the moles, you're going to find the volume. That's the only difference you have in this case. So up till finding the moles, everything is exactly the same. So first step, write the half equation that is taking place for the fluorine gas. So you have 2 moles of fluoride ions, that is releasing 2 moles of electrons to form 1 mole of fluorine gas. Mind you, it is, even if it is F2, it is 1 mole of fluorine gas. So don't get confused. Right, now find the charge required to form 1 mole of fluorine gas. It's going to be 2 times Faraday's constant, because mind you, the ratio is 1:2, right? So you need 2 times Faraday's constant. Again, Faraday's constant is the amount of charge on 1 mole of electron. So 2 times 96,500, that is going to give you the exact same 193,000 coulombs of charge required to form 1 mole of fluorine gas. Now, the amount of charge provided exactly the same as previous. I times 3, 3.2 times 3 times 60. That is going to give you 576 coulombs of charge. Next step, find the moles of fluorine gas produced, right? Now, what you have over here is again the same ratio. The amount of charge provided divided by the amount of charge required to form 1 mole of fluorine gas. However, there will only be 0.00298 moles of fluorine gas, right? So you divide these and you get this. Now, to find the volume of fluorine gas, you can do either of two things. If you want your answer in dm cube, you will multiply the moles 0.00298 times 24 and you'll get 0.0715 dm cube, right? Or otherwise multiply with 24,000, which will give you the answer in cm cube, right? So this is your answer for the volume of fluorine gas that will be produced. By the way, if you don't know, for this at least, you need the pressure to be 1 atmospheric pressure. So you're considering that because in 1 atm, 1 mole of any gas will occupy 24 dm cube. That is a given. So you probably do know that from O levels, right? 1 mole of any gas will also occupy 24,000 coulombs, which is exactly the same thing. Sorry, 24,000 cm cube. What am I saying? 24,000 cm cube, right? So 24 dm cube, if you convert it, 24,000 cm cube. Okay, so using that, we can find the volume of gas that will be produced. Okay, fair enough. Now, that is it for this video. So in this video, we learned how to find the amount of mass being produced and the volume of the gas being produced, right? So see you in the next video.